Welcome to part 3 of Eco Design Engineer for SolidWorks. In this part, we are going to use the applications included in the Eco Design Engineer role in order to perform a process-based lifecycle assessment of a model created in SolidWorks. We will use the results of that lifecycle assessment in order to find the environmental impact hotspots of that product. The agenda for this presentation is first, we will review the scenario, so we'll look at the model and look at some characteristics as to where it's manufactured and how it's manufactured. Then we'll get into the business value definition application where we will define the human activities. Here we will explore how to use the EcoInvent database in order to define the human activities, which in turn develops the lifecycle assessment. Next, we'll look at how to incorporate purchased parts into your lifecycle assessment, and then we will review the lifecycle assessment results. This is the model that we will be using to perform our lifecycle assessment. This is a hand crank assembly that was produced in SolidWorks. So for our company manufactures 4 of the parts in this hand crank assembly. There's the 2 yokes and the spider pivot. Those are cast and machined aluminum. And then there's the main bracket, and that's stamped aluminum. To produce this hand crank assembly, our company purchases the handle. The environmental impact of that handle is understood through an environmental product declaration provided by the supplier. And then our company also purchases the 3 stainless steel pins that join the 2 yokes to the spider pivot. The location of the different operations is another part of this scenario. Our company has a main assembly facility near Prague in the Czech Republic, and our company has a foundry near Bratislava in Slovakia. The supplier of the purchase parts is located in Berlin, and so the transportation between these 3 locations will be included in our lifecycle assessment. Note that in this demonstration, the lifecycle assessment will be a cradle-to-gate lifecycle assessment, and this means that we will be considering the upstream environmental impacts up to the point of final assembly in the Prague main assembly plant. So coming to the 3DEXPERIENCE platform, again, we will be using the Eco Design Engineer role. There are many apps, again, within the Eco Design Engineer role, and the first app that we're going to use in order to define our lifecycle assessment is an app called Business Value Definition. So I have already loaded our hand crank assembly here in 3D Navigate, and we can explore the hand crank assembly. There's the main bracket, these are the 2 yokes, the pivot, and then these are our purchase parts. And this hand crank assembly has also been loaded into business value definition. So if we make that full screen, we can see all of the components that make up the hand crank assembly. So in business value definition, here you can select the different environmental methods. We could be looking at EPS 2020 or the recipe method, Tracy used by the US EPA. But for the purposes of this demonstration, we're going to stick with IPCC 2021 as our environmental method, and that focuses on CO2 emissions. And we're doing this just for simplicity so that we're not considering a very wide range of environmental impacts. It's very easy to switch between environmental methods later on, but we'll be focusing on IPCC 2021 for now. Now that we are in business value definition, what we are going to do is define human activities for all the parts that make up the assembly. Human activities are the elements of the lifecycle inventory. They represent the processes that go into producing the parts and also the final assembly of the hand crank assembly. We'll get more into this next. It is important to note that the boundary for this lifecycle assessment will be cradle to gate. This is a lifecycle assessment that includes all of the upstream activities that went into producing the parts and transporting the parts to the final assembly area. It also includes any energy consumed during final assembly and the production of the packaging so that the product is ready to leave the facility, and that is the gate. This is opposed to a lifecycle inventory that would perhaps be cradle to grave, where we would include all of the cradle to gate activities, plus we would consider product use phase activities as well as end-of-life treatment of that product when it's ultimately disposed. So if you remember, we have 3 parts that are cast aluminum and then they are machined, and this is all done in the facility in Bratislava. Then those parts are shipped from Bratislava to the assembly facility in Prague. To capture that, we need to define human activities, and we're going to define these human activities for the outer yoke, the spider pivot, and the inner yoke. So starting with the outer yoke, I have the option to add a human activity. you will search for your human activities in this search box. And essentially what you're doing is searching the EcoInvent database. So again, this is a cast aluminum part that is then machined and shipped from Bratislava to Prague. First, let's search for cast aluminum alloy. And so this is the human activity for the material. We see it listed here. This provides a brief description of the human activity, and if we wanted to learn more, we could, of course, view the documentation, and this is the EcoInvent documentation for that human activity. If I go ahead and open it, we're looking at the market for aluminum cast alloy, and this is a global human activity, and that includes the production of cast aluminum alloy plus transportation. This is transportation to the consumer of the aluminum alloy, and in this case, that is an average transportation for shipping cast aluminum alloy to the Bratislava facility. I'll press next. For geolocation, we can come in here and say that we want Slovakia. And we're going to include that as a raw material. Then I'm going to go ahead and attach that human activity. So let's define more human activities. Next, I want to capture the impacts associated with machining the cast aluminum part. So here I'm going to look for the market for metalworking, and this is an average for aluminum product manufacturing. Here it came up in the search. Again, I can read more about it. I can go to the documentation, but this is the human activity that I want. I'll press next. I'm going to assign it to manufacturing. And again, in geolocation, I'm going to select, I could also select from a list of countries here. Might be a little bit easier because Slovakia is rather small. Here we go. Hit save and attach. So next I want to capture the transportation from the facility in Slovakia to the assembly plant in Prague. So I'm going to add a human activity for transportation. Here I'm going to look for market for transportation in a lorry weighing between 7.5 and 16 metric tons, and it's of the type Euro 5. So Euro 5 is a designation related to emissions control systems within these trucks. So here it is. I'm going to press next, packaging and transport, and I'm going to say 320 kilometers. That's the distance between the facility in Slovakia and Prague. And I can come here and I will look for Slovakia, save selection, and attach. In the previous step, I added human activities in business value definition. It is important to note that in order to find the correct human activities, I searched through the list of human activities available in business value definition. I reviewed the documentation for each of those human activities, also reading the short description. And in some cases, I had to look in other online resources to understand that that human activity was the correct human activity for my application. Some of these online resources include the EcoInvent website. They have a tool called EcoQuery, allows you to review human activities produced by EcoInvent. And they also have an excellent YouTube channel. And I highly recommend watching some of the introductory presentations for the EcoInvent database. You can also use AI-assisted search, where you describe the product, materials, the manufacturing process, transportation, things like that, and the AI-assisted search would recommend activities from the EcoInvent database that may be applicable. So back in business value definition, we can see here the 3 human activities that we have added for the outer yoke. If I click here, and I can see that I have applied 1 human activity to raw materials, 1 to manufacturing, and 1 for packaging and transport. As we said previously, the spider pivot and the inner yoke would use the same human activity. Within business value definition, I can simply copy the sustainability data and paste it to the 3 parts that use the same human activities. These parts are all created from aluminum, they are manufactured in the same way, and they're transported from the same plant in Bratislava to Prague. Next, we're going to define the human activities for the main bracket. Now, the main bracket is made in the same facility, but instead of being cast aluminum, it is a sheet metal part. So what we can do is we can copy the sustainability data from one of these other parts, but we want to remove the market for aluminum cast alloy. So I'll come here, hit delete, and then I'm going to add a human activity. In this case, I want the market for sheet metal rolling aluminum, or I should say aluminium. Here it is. One thing I can do is I can add this human activity to my list of favorites. This is highly recommended, especially in this situation where you will likely reuse the same human activity because you're manufacturing a series of similar parts. They're either similar in the same material or manufacturing process, or in some way that they would use the same human activity. So I'm going to go ahead and attribute that to the raw material and select Slovakia. Now we have the human activities assigned for the 4 parts that are manufactured by our company. Let me give you a few tips about searching for human activities in business value definition from the EcoInvent database. In business value definition, the human activities are listed using UK English as opposed to, let's say, American English. So when I was looking for an aluminum part, I was actually looking for an aluminium part and had to spell it aluminium. When I was looking to define a human activity for truck transportation, I was able to find the human activities looking for transportation by lorry, which is again the UK English term for a truck. Another important tip is that often in business value definition when searching for human activities, very specific naming is used. So if I were looking for ABS plastic, I may have trouble finding ABS plastic, but if I instead searched for acrylonitrile butadiene styrene, then I would find the equivalent of ABS plastic. Another example is looking for chromium steel as opposed to stainless steel. One thing that can be helpful is if you are familiar with the International Standard Industrial Classification categories, or the ISIC categories, you can use those to filter the list of human activities. A few other things to discuss. First, you saw when I was defining human activities that I specified a geography where the activity took place. So we will see when we view results how that geography is used. It is also important to note that in the list of human activities, some of those human activities are specific to a geography. If I select a geography for my human activity and one of those geography-specific human activities exists, then that human activity will be used. If there is not a geography-specific human activity for the human activity I selected, then a rest of world human activity or a global human activity will be used that is not geography-specific. Another thing to point out is that you will notice that many human activities are labeled as market for type human activities. So let's look at an example between tin production and market for tin to understand the difference between these two human activities. So I have searched for tin in the list of human activities. Here's tin production, and I've downloaded the documentation. And so here I have tin production, the documentation for tin production, and here I have market for tin. Both of these have the same reference product, or the output of that process, and the output is the metal tin. In tin production, we see that this is considering all of the upstream emissions for a tin metal manufacturer. So I guess a smelting plant or a factory where the output of that factory is tin. And so you can see quite a list of activities that are considered, and they're also combining other upstream human activities in order to define tin production. If I go to market for tin, here it has tin production as, or I should point down here, here we see tin production as one of the included human activities. In addition to this, it has added human activities related to transportation. So this is a market activity is a consumer activity. So someone purchasing tin to use in their products would incur the emissions or the environmental impacts associated with tin production, plus the environmental impacts associated with distributing tin to a final consumer. And so that's really the difference between a human activity labeled as market for versus a very similar or basically identical human activity that is not labeled market for. Market for considers things like transportation and losses that would be incurred in getting the product to a consumer. So we've defined the human activities for all the parts that are manufactured in our company's manufacturing plant in Bratislava. Now to complete the LCA, we need to consider the purchase parts, and we'll explore two strategies to perform a lifecycle assessment that includes purchase parts. The first will be to simply assign human activities to those purchase parts. So here we can see that we have 3 pins that are purchased from a company in Berlin. And remember, this our company, or the assembly plant, is in Prague. So these are shipped from Berlin and sent to Prague. So we'll come here to this first pin, define a human activity. We're going to look at milling for chromium steel. Here it is. And I'm going to add this to my list of favorites. Hit next. That's a manufacturing part of the life cycle. I've set the geography to be Germany, and I'm going to go ahead and attach that human activity. Now let's define the raw material. Here it's chromium steel. I'm going to use the market for chromium steel. I'll also add that to my favorites. That'll be the raw material. Set the location to Germany, and I will attach that. Then I'm going to add 350 kilometers of transportation from the facility in Berlin in a Euro 6 truck with a capacity of 16 to 32 metric tons. And I'll also add that to a favorite. That is packaging and transportation, and we're going to enter 350 kilometers, set the location as Germany, and we're going to attach. So we've defined the human activities for these 2 pins, and it's exactly the same human activities that we define for the long pin. I could, of course, copy the sustainability data from the short pin to the long pin, or I can come in here and add human activities and select the human activities from my list of favorites. In here we see those human activities that I recently added to my list of favorites. And so here I added the same human activities from my list of favorites. Let's complete the LCA by considering the purchase crank. So this purchase crank is bought from a facility in Berlin that's then shipped to Prague, so the same distance as these purchase pins, same facility. That company that sells the purchase crank says that the emissions for a purchased crank is about 4 kilograms of CO2 equivalent. So those are cradle to gate emissions, essentially all of the upstream emissions associated with producing one of these cranks right up until the point that that company is ready to distribute the crank. So they're saying that that is 4 kilograms of CO2 equivalent. We can enter that information by clicking here in the value column, and we come over and we'll say it's 4 kilograms. We'll give it a tolerance of plus or minus a kilogram with a confidence of 80%. Go ahead and hit save. So now we've declared that for that component, that hand crank subassembly, the CO2 emissions associated with producing that component are 4 kilograms of CO2 equivalent. Let's also then come in here and we're going to add the human activity from our list of favorites for transporting that hand crank from the facility in Berlin to our assembly plant in Prague. Say it's packaging and transport. Select Germany as location. We're going to say it's 350 kilometers from the facility in Berlin to our assembly plant. So now we've defined all of the human activities that went into creating the components that make up this hand crank assembly. In other words, we have completed the life cycle inventory, and now let's move on to the life cycle assessment. Before we move on, I did forget to add the cardboard box that we had considered. So we'll come in here at the high level, add a human activity. I'm going to search for cardboard box. There we go. Market for corrugated box. And if I used value from rollup, that would take the weight of the hand crank assembly, and that's not really what we want. We know that the cardboard box will weigh about 0.2 kilograms. So now we've added the cardboard box. Before we move on to analyzing the results of our life cycle assessment, I would say that the question could be asked as to why the application used to define the human activities for the life cycle inventory and then the life cycle assessment is called business value definition. Why isn't it called something like life cycle assessment or human activity definition or something like that? The reason is that the application business value definition is not only used for life cycle assessment. Business value definition is an application available in many roles that allow users to add business intelligence information to their product designs. Adding this wealth of information allows for simulation and analyses beyond the CAD model. This elevates the CAD model from a digital twin to a virtual twin on the 3DEXPERIENCE platform. Some of the other roles that include business value definition are weight and balance. This allows organizations outside of the group of CAD engineers to understand and utilize the mass properties information of the product designs. There's a role for costing, and this provides a wide range of costing analysis tools for an organization's products. And then materials compliance. This enables companies to collect, track, analyze, and report a product's environmental compliance against chemical substance or material content regulations. By providing the ability to perform these complex analyses, 3DEXPERIENCE platform users are given a comprehensive suite of tools that will allow them to reduce the environmental footprint of their products. To give you a quick example, along with my license of Eco Design Engineer, I also have a license of Weight and Balance Manager. So if I come here, I can select the different environmental methods for my life cycle assessment, but I can also select that I want to view the business intelligence information for weight and balance. And here we can see the mass properties of the parts that make up this hand crank assembly. By adding human activities to the components that make up the hand crank assembly, we define the life cycle inventory for that assembly in business value definition. Eco Design Engineer automatically generates the life cycle assessment from that information. So let's go ahead and view the life cycle assessment for the hand crank assembly. So we're going to minimize business value definition, and you can see that I've created a second tab on my dashboard, and this is results. And what I did is I dragged the application Eco Design Assessment onto this tab, and you can see that we have 3D Space, Product Structure Explorer, and 3D Navigate. To view the lifecycle assessment, I simply drag the hand crank assembly into Eco Design Assessment, and I'm going to select the IPCC environmental method. And here we can see that the hand crank assembly has a total carbon footprint of 6.874 kilograms of CO2 equivalent. I can click in and explore this a bit more. So here we can see the components that contribute most to this carbon footprint, and so we see that that purchase crank is rather significant, but so are the inner yoke, the main bracket, and the outer yoke. I can come here and see which phase contributes most to the carbon footprint, and it's either raw materials or manufacturing. It says uncategorized because that is the 4 kilograms from the purchased hand crank lever. We can come in here, look at the geolocation distribution, and we can see that most of the impacts are incurred in Slovakia, and some of the impacts are incurred through activities in Germany. And here we can see the top human activities contributing to the total environmental impact for the hand crank assembly. We can, of course, view this information for the individual components. So if I click here and open up the inner yoke, we see the inner yoke opens in a new tab. We can see the top human activities that make up the inner yoke. We can look at the phase-wise distribution to see that raw materials are the most significant contributor to greenhouse gas emissions for that component. You can also view the geolocation distribution and see that it's all in Slovakia in this case. In part one of this series of videos, we talked about all of the different environmental impact or damage categories that are calculated in a life cycle assessment. We narrowed it down just to IPCC 2021 as our environmental method, and that was so that we could focus only on CO2 emissions. However, if we want to look at the other environmental impacts associated with our life cycle inventory, you can choose one of these other environmental methods. So if we go to TRACY, this is the US EPA method, you'll see that they are calculating environmental damage categories not only for global warming, but also for water eutrophication, air acidification, ozone depletion, photochemical oxidation, and many other environmental impacts. And so it's very easy to switch between the different environmental methods in Eco Design Engineer. In each of these methods, you'll notice that perhaps the common environmental impact categories may have a different calculated value, and that is a result of the different calculation methodologies in each method. But you can see that it's roughly the same between IPCC and also TRACY. To wrap up, in part 3, we saw how to use Eco Design Engineer to perform a life cycle assessment in order to find the hotspots within a product, process, or service. We used the application business value definition to define the human activities, and in one example, to specify the environmental impact. You remember we specified that the hand crank lever itself had a carbon footprint of 4 kilograms of CO2 equivalent. Then we used eco-design assessment to view the LCA results and see the hotspots within our design. And again, we are performing hotspot analysis. In part 4, we'll use comparative LCA, so essentially comparing one design to another design alternative in order to reduce the impact of our product. Thank you for watching my presentation.